All right, here is problem 2 from tutorial 2. So here we have a function that is defined by a piecewise formula. So why does it have to be defined by a piecewise formula? So notice that uh, the kind of at all points except at 0, 0, the formula is x times sine of 1 over x squared plus y squared. But at 0, 0, so we just define it to be 0. So why do we have to do it? Is because, if x is 0 and y is 0, and if you just try to substitute 0, 0 into the equation, then you will get 0 times sine of 1 over 0 squared plus 0 squared, and basically it's sine of 1 over 0, which is undefined. So at the same time, by the way, it's not hard to prove by the squeeze theorem that if x and y approach 0, 0, then this sine thing is just bounded, and then x approaches 0. So the limit is actually 0. So this function is in fact continuous at the point 0, 0. All right, and here we have three parts in the problem. So in the first part, we need to differentiate it just by the differentiation rules. So we need to find its partial derivative with respect to x when x and y is not 0, 0. So which means we've got to just use the formula. And then in part B, we've got to find the definition of partial derivative to find its partial derivative with respect to x at 0, 0, which means we've got to use the definition, since we cannot use differentiation rules, since there's no single formula for the function. And finally, we will find the second partial derivative. Okay, so let's do it part by part. In the first part, we've got to just differentiate it according to differentiation rules. So how do we do that? So this is the product of x and sine of whatever. So we've got to differentiate it by the product rule. Right? So x is going to be, so first we differentiate x with respect to x, and its derivative is just 1 times sine of 1 over x squared plus y squared, plus, now we keep the first multiplier x times the derivative of the second one. So now the second one, we've got to differentiate it by the chain rule. So first we differentiate the sign. So differentiating the sign, we get the cosine of 1 over x squared plus y squared. So now we need to differentiate the argument of the sign, 1 over x squared plus y squared. So times 1 over something, its derivative is minus 1 over the same thing squared. So minus 1 divided by x squared plus y squared squared. And finally, we've got to differentiate x squared, right? So because we still haven't differentiated it, so, and its derivative is 2x. And now we can simplify it into sine of 1 over x squared plus y squared plus, or rather minus, I guess. So let me write minus here. So minus, there is x times 2x, so it's just 2x squared divided by x squared plus y squared squared times cosine of 1 over x squared plus y squared. Okay, that's the answer to part A. Fairly straightforward. Now, part B. So in part B, we've got to find the partial derivative at 0, 0. And notice that by definition of the function, so f of 0, 0 is actually 0. Right? So to do this, we've got to use the definition. Right? So we've got to use the limit as h goes to 0 of f of 0 plus h 0 divided minus f of 0, 0 divided by h. Right? So now f of 0 plus h0 comes from the formula, and f of 0, 0 is just 0. Right? So this is the limit as h goes to 0 of, well, basically 0 plus h is of course still 0, so I don't have to write 0 plus, I can just write h. So I need to replace basically x with h, and y with 0 in the formula. So this is h times sine of 1 over h squared plus 0 squared, everything divided by h, and minus 0. So now let me just simplify a little bit. Minus 0 is, of course, doesn't do anything. Okay, then h divided by h is basically 1, and this is um, just nothing again. So the whole thing is the limit as h goes to 0 of sine of 1 over plus of 1 over h squared, and it is well known from mathematics 1 that this limit does not exist, right? So which means that f of f differentiated with respect to x at the point 0, 0 is just undefined. Okay, and in problem 3 we've got to find the second partial derivative with respect to first by x and then by y. So how do we do that? Right. So to do that, you need to realize that. So what is it? So f x y is actually first we start with fx, and then we differentiate it with respect to y. Right. So let me write down the definition of differentiation with respect to y. So this is really the limit as h goes to 0 of fx evaluated at the point x, y plus h minus fx evaluated at the point x, y divided by h, right? So this is the general definition of what second partial derivative means, right? So because we've got to start with the first derivative and then differentiate with that. So in our case, fxy evaluated at the point 0, 0 is going to be the limit as h goes to 0 of fx evaluated at, so x is now 0 and y is 0, so 0 plus h is just h. So, and this is calculated in, this partial derivative of f with respect to x evaluated at 0h is in fact calculated in part A, right? So let us fill it in later. So minus fx evaluated at 0, 0 and divided by h. Okay, so now this expression here is calculated in part A, and this expression here is calculated in part B. But in part B, we found that this is actually undefined. So, and of course, if we want to compute the value of some expression that involves something that is undefined, then we still get something that is undefined, right? So, which means that the answer is still undefined or does not exist.